Welcome to section 10.6. In this section we're going to look at radical equations and then we'll do a couple of applied problems at the end, but the main focus is going to be on radical equations. So radical equations are exactly what it sounds like. Equations like this that have a radical in them. Typically radical equations are going to have variables underneath that radical. So in order to solve, you would have to get the variable out from under the radical, and that's what we're going to learn how to do in this section. Okay, the trick to eliminating that radical, getting rid of that radical so that the x will be out from under it, is to, if it's a square root, square both sides of the equation. Okay, so let's do this example right here. We have the square root of 3x minus 2 is equal to 5. And we want to find what value or values of x make this equation true. Well, to eliminate this radical here, if we square both sides of the equation, because remember you can do anything to an equation as long as you do it to both sides, then the square root and the square cancel. So on the left we just have 3x minus 2, and on the right we have 25. And then from here it's fairly simple to solve. You just add 2 to both sides and divide by 3 to get 9. Now don't immediately circle your answer. Okay, when you're solving radical equations, what you effectively do is you're multiplying both sides of the equation by a variable, essentially, because you're squaring them. So there are some variables that you're multiplying both sides by. And anytime you multiply both sides of an equation by a variable, or square or cube both sides of an equation, you must check your answers because there's a risk that you might accidentally introduce what's called extraneous solutions. And that's what this down here says. Anytime you raise both sides of an equation to a power, you must check all your solutions by plugging them back into the original equation, because you may have introduced extraneous solutions, which are answers that you get but don't really solve the original problem. So in this example, if we check x equals 9, let's plug that in up here and see if it works. Okay, does the square root of 3 times 9 minus 2, does that equal, and put a little question mark there, 5? Let's see, the square root of 3 times 9 is 27 minus 2. That's the square root of 25. And yes, the square root of 25 does in fact equal 5, so that is an answer. And in this case, it was the only answer to that equation. Okay, from here on out, make sure you're pausing the video, trying each problem first on your own. All right, the next example is this one. Now, if you notice, this one is a little different than the previous problem in that the radical is not by itself. In this previous problem, the radical was all by itself on one side of the equation. So when we squared both sides, that radical simply went away. Now on this one, the radical is not by itself. So if we were to square both sides at this step, okay, this is wrong, what I'm about to write, but let me show you why it's wrong and why this doesn't work. Okay, if I was to square both sides at this step, the radical would not go away because you would have to FOIL this out. Remember, this would really be square root of 9x minus 2 minus 2x times itself. So times the square root of 9x minus 2 minus 2x equals 0. Then when you FOIL, you would get square root of 9x minus 2 times square root of 9x minus 2, which is 9x minus 2. The radicals go away. Your outside terms then would give you minus 2x times the radical, and that right there is why the radicals don't go away. It's because of these two outside and inside terms. Okay, so I'm going to stop right there. You would keep going on from there, but like I said, that is all incorrect. Instead, what you have to do to get rid of the radical is first isolate the radical. So first I'm going to move everything else to the other side. So the 2x, let's add to both sides to give us 9x minus 2 equals 2x. Now we can square both sides. And make sure you square everything. You should just put a big set of parentheses around the whole side of the equation and square the whole thing. On the left, square root and square cancel to give us 9x minus 2. And on the right, remember we have to square everything, both the 2 and the x, to give us 4x squared. Well, this time it looks like we have hopefully you recognize this is a quadratic equation. So then you would start thinking of techniques. How do I solve a quadratic equation? Well, you move everything to one side to get it equal to 0. I'm actually going to keep the 4x squared on the right because I like to have a positive coefficient in front of my leading variable. And I'm going to move the 9x and the 2 over to the right. So I'm going to write it as 0 equals 4x squared minus 9x plus 2. And this may or may not factor. Let's try it and see if we can get it to factor. Let's see, the last terms, one will have to be a 1 and one will have to be a 2 for them to multiply to 2. The middle term is negative, so both of these must be negative in order to multiply to positive. So let's try a 4x and a 1x. The other possibility is to do a 2x and a 2x. And I could also switch the 4x and the 1x. That could work as well. Let's see, if I do it like this, when I FOIL, I would get 4x squared minus 8x minus 1x, which is minus 9x, plus 2. So it looks like that works. Then I can set each factor equal to 0 and solve from there. So over here we get 4x equals 1, so x is 1/4. And over here we get x equals 2. And remember, you have to check your answers by going back to the original equation. Okay, I've plugged in 1/4. I'm just going to keep going with this and see if I get 0. So we have the square root of 9/4 minus 2. I'm going to need a common denominator, so how about 9/4 minus 8/4? And then this is 2/4, which is 1/2. 9/4 minus 8/4 is 1/4. So that gives us the square root of 1/4 minus a half. Square root of 1/4 is the same as the square root of 1 over the square root of 4. Or you could just ask what fraction is there so that when you square it you get a 4th. And that is a half. And a half minus a half is 0. So we did get this 0 on the other side that we wanted. Okay, let's check so that one is a solution. Let's box it in. Now let's check x equals 2. That's supposed to be an equal sign there. It's not a negative or anything. Checking that. We have the square root of 9 times 2 minus 2 minus 2 times 2. 9 times 2 is 18, minus 2 is 16, so that gives us square root of 16. Minus 4, square root of 16 is 4, so yes, that is also 0. Both are, in fact, solutions. Okay, so if you have a radical equation and the radical is not by itself, remember to isolate the radical on one side of the equation first. Get it completely by itself before you square both sides. And here's another example. This one is slightly different because it is a cubed root. Okay, but the same process applies. There's only a very slight difference in the process used. But first, we will want to isolate the radical and get it by itself. So let's subtract 2 from both sides. 1 minus 2 would be negative 1. Okay, now at this point, this is not what you do, what I'm about to do. This is wrong. If we were to square both sides, would the radical and the square cancel? Would this index and square cancel? The answer is no, because we have a cubed root being squared. That's the same as x minus 5 to the 2/3 power. That they don't cancel. So instead of squaring both sides, if you have a cubed root, you would actually need to cube both sides in order for this cubed root and that cube to cancel. So it just depends on what the index is. If it was the 4th root, you would raise both sides to the 4th power. And that's the only difference between solving this and solving the square roots. Okay, so, and then from here you just solve. This one's very easy to solve. X minus 5 equals -1. Add 5 to both sides to get -1 plus 5, which is 4. And let's do check. You will run across some where the answers don't work, I promise. The cubed root of, let's see, 4 minus 5 plus 2. Let's see if that equals 1. That would be the cubed root of -1. And the cubed root of -1 is -1. Oops, 2. That does equal 1, which is what we wanted to get. So that's it for that problem. So if you have a cubed root, you cube both sides. We have the square root of 9 plus x is equal to x plus 3. Now this one is already started for us because the radical is already by itself on one side of the equation, so we don't have to isolate it first. Instead, we can just begin by squaring both sides. So we have the square root of 9 plus x is equal to x plus 3, and I'm going to square. Remember, you don't just square every term, you square both whole sides. So on the left, we have 9 plus x. On the right, what a lot of people would forget to do here is FOIL. This really means x plus 3 times itself, times x plus 3. So we would need to FOIL that out to get x squared. Plus 3x will give me a plus 6x in the middle, plus 9. So it looks like this one gave us a quadratic equation. So to solve a quadratic, you get everything on one side, set it equal to 0, and we will see if this factors. I'm going to move this 9 plus x over to the right side. So if I do 6x minus x, that gives me 5x. And 9 minus 9 is 0, so those cancel. Now this one's fairly easy to solve because both terms have an x in them, so we can just simply factor out an x, and we're left with x plus 5. And then we set each factor equal to 0 to give us x equals 0, and x plus 5 equals 0. X equals 0 is already solved for x. And then over here, move the 5 over to get x equals -5. Before I circle my answers, I'm going to check. First, I'm going to check x equals 0, and it's a good idea to label which one you're checking if it's not necessarily clear by the way your work is organized. So I'm going to first check x equals 0. So square root of 9 plus 0. Does that equal 0 plus 3? See, square root of 9 is 3, so yes, that one works. So that is a solution. Now let's check x equals -5. That would give us the square root of 9 minus 5. Does that equal -5 plus 2? See, the square root of 9 minus 5 is equal to the square root of 4. Does the square root of 4 equal, oh, that should have been a 3 there. Look at that, x plus 3, so it should have been -5 plus 3. So does the square root of 4 equal, see, -5 plus 3 is -2. Square root of 4 is defined only to be, remember, the positive of that radical. So it's 2. And 2 does not equal -2. So that one is actually not a solution. So in this case, we did actually introduce an extraneous solution when we squared both sides. So the only answer here is x equals 0. Okay, let's move on to a more complicated type of problem. And that's when you have 2 or even more radicals in a single equation. When that happens, you really still follow the same process. You get one of the radicals by itself, doesn't matter which one, square both sides or cube both sides or whatever, and then simplify as much as you can. And then if there's still another radical, isolate it and square both sides again. So you just repeat the process as many times as necessary, isolating a radical and squaring both sides, isolating a radical and squaring both sides, and eventually all the radicals will go away. So on this one, it does not matter which radical we start with. So I'm going to start with isolating this, the 3x plus 1 radical, by subtracting the radical 3x to the other side. Now I'm going to square both sides. So I'm just choosing to isolate this bigger radical first. Square root of 3x plus 1 all squared is 3x plus 1. And of course, don't forget to FOIL. I'm going to write it out to make it a little easier to see here. Don't hesitate to write a lot of steps. If it helps prevent you from making a mistake, just write the step out. Okay, FOILing gives me 2 times 2 for my first term, which is 4. My outside terms, 2 times negative radical 3x will be minus 2 radical 3x. The inside terms, negative radical 3x times 2, again, minus 2 radical 3x. And my last two terms are negative times a negative, so it will be positive. Radical 3x times radical 3x, so the radicals cancel to give us 3x. Okay, so we still have 2 radicals, but the nice thing is these are actually like terms right here. They have the exact same radical and the exact same radical, so we can simply add their coefficients to combine those. So in the next line, let's just combine those on this next step. So the next line will give us negative 2 minus 2 radical 3x is minus 4 radical 3x. Then other things we can do to simplify are we could subtract 3x from both sides, and as you can see, if we do that, they will cancel each other out. Okay, so it's getting a lot simpler here. So we now only have 1 radical left in the equation, and that is great. So we've made progress, so now we start the process over. We isolate this radical and then square both sides. So I'm going to subtract this 4 over to get it out of the way. 1 minus 4 is negative 3. So negative 3 equals negative 4 radical 3x. And let's go ahead and divide both sides by negative 4. Now at this step you actually do not have to get rid of that negative 4 because if you squared both sides, the radical would still be eliminated. But just to be consistent, I'm going to go ahead and divide both sides by negative 4 to get this. And now that that radical is by itself, we can square both sides. See, 3/4 squared would be 9/16 equals 3x. Let's come way up here. Don't hesitate to draw arrows like that to help organize your work. So we need to divide both sides by 3. Before I multiply the 3 times 16, look, we can take a 3 out of both the 9 and the 3. So don't even have to multiply those. So we get x equals 3/16. Okay, and let's check. It won't be as difficult as it looks to check. Does the square root of 3x, which is 3/16, plus 1, plus the square root of 3 times x, which is 3/16. The question is, does that equal 2? Let's see, 3 times 3/16 is 9/16. I'm going to need to add that to 1, so 1 I'm going to rewrite as 16/16 plus the square root of 9/16. Does that equal 2? So we have 9/16 plus 16/16. 9 plus 16 is 25. Okay, this radical I can go ahead and take. Well, we'll do it in the next step just to be consistent. Okay, now I can take both these radicals. Square root of 25 is 5, and square root of 16 is 4. Square root of 9 is 3, square root of 16 is 4. 5/4 plus 3/4. Adding the numerators gives us 8/4. And yes, it is true, 8/4 does equal 2. So that is, in fact, a solution. And the only solution in this case. So if you have 2 radicals, first get 1 radical by itself, square or cube both sides, simplify as much as possible. Then if there's still another radical, isolate it and square both sides and solve from there. That's it for theoretical problems. Now let's look at a couple of applied problems. These are actually fairly simple problems compared to the ones that we just worked, but that's okay. It's always a good idea to work some applied problems so you can work on those skills. All right, the question here is to find the length of the unknown leg in the right triangle shown here. Okay, well, there's no variables in this problem, you might notice, so you can introduce your own. Let's just call that x, And the way you introduce it is just by writing it on the diagram. That lets you and me both know how you're defining x, what x is. Okay, so in other words, we want to find x then, if we want to find the length of the unknown leg. Okay, so what do we know about a right triangle and its side lengths that could help us solve for x? Hopefully this rings a bell. You might remember the Pythagorean theorem, which says that the length of one leg squared plus the length of the other leg squared is equal to the length of the hypotenuse squared. So in this case, x squared plus, that's the first leg, the other leg squared, 6 squared, is equal to the length of the hypotenuse squared, which is 9 squared. So in solving this for x, this is not even really a radical equation. This is a fairly simple equation. You have x squared plus 36 equals 81. So we subtract 36 from both sides to get 45. And then we take the square root of both sides to isolate x. And remember, typically if you take the square root of a variable squared, that means the other side could be positive or negative. However, this is the length of a leg of a triangle, and a length can never be negative. So we're just going to ignore that negative solution there and go with the square root of 45. Now let's see if that simplifies. 45, we can take out a 5, which would leave us with 9. We can take out a 3 and a 3. So we can simplify that to 3 radical 5. And the units in this case are centimeters. Don't forget your units. Okay, let's do one more example. A furniture upholsterer wishes to cut a strip from a piece of fabric that is 45 by 45 inches. The strip must be cut on the bias of the fabric, and that just means a 45-degree angle. So what is the longest strip that can be cut? So let's give an exact answer and a 2 decimal place approximation. Okay, so here's a picture here. We have 45 inches by 45 inches. This is the length of that cut that we're trying to find. Again, we can introduce our own variable. X is always commonly used. However, this is a hypotenuse, so you could also call it h for hypotenuse. I'll do that in this example. So we want to find h then. So again, we have a right triangle indicated by that little square there. So the length of the first leg squared, how about that 45 there on the bottom, plus the length of the other leg squared is equal to the length of the hypotenuse squared. So let's see, 45 squared, that's one you would definitely do in your calculator. It's equal to 2025. So 2025 times 2 is 4050. And then to solve for h, we can take the square root of both sides. So h would be plus or minus the square root of 4050. Of course, we're going to ignore that negative answer because a negative number would not make sense in an applied problem such as this. Now let's see if that simplifies. So 4050, it looks like this would be hard, but it's really not. When you just start dividing by prime numbers, it gets small very fast. We know if we divide by 2, we get 2025. Now, it ends in a 5, so I know that's at least divisible by 5. Dividing that by 5 gives me 405. It ends in a 5, so I can divide it by 5 to get 81. 81 I know is equal to 9 squared, so and 9 is divisible by 3, so I can divide that by 3 to get 27. Divide by 3 to get 9, divide by 3 to get 3. So let's see, we can take out a 5s, pair of 3s, and another pair of 3s. So out front we have 3 times 3 times 5. That's 9 times 5, which is 45. And the only thing left under the radical is that 2. So 45 radical 2. There's the exact answer. We also want to give a 2 decimal place approximation. So that's approximately equal to, you just use your calculator. 45 times the square root of 2 is about 63.6 0.396, and the units here are inches on both of these. Okay, that's it for radical equations and just a couple of applied problems to keep you working on those. Next we have section 10.7, which will be the last one in chapter 10 for this week.